The input was kind of complicated. We had to start by putting the input on the tape. It raised questions about, well, now we don't necessarily know without looking at both the size of the input and the number of steps where the last non-blank was. So let's get rid of the input. Let's just say the tape starts as all blank. There's no input. Are we happy with this? Does it make sense to have a computing model that has no input? Certainly our Boolean circuits didn't make a lot of sense if we got rid of input. Can we get the input back if we need it? Or can we do something to make this equivalent? So let's assume we had our old model where we have a Turing machine and an input x, and now we want to execute in the simpler no input model. Can we produce a new Turing machine that doesn't take any input, but will produce the same output as the original machine would have running on input x? So now this machine is going to start with a blank tape, and it should produce the same output as the original machine would have, starting on a tape that had input x on it. Can we define this machine? Yeah. Exactly, yeah, right. All we have to do, we got to have a machine. This is going to be our m prime. It's going to have a transition function that says in state 0, we're going to read a blank, and we're going to write the first input, and we're going to move to the right. And we're going to go to state 1. In state 1, we're going to read a blank. We're going to write the next input, and we're going to move right, and so on. So we're going to have a bunch of states. How many are we going to need to write the whole input? Yeah, n of them, if it was length n input, right? We're going to have n states. That's going to write the last one. And what do we do after state n? Because now we got to get back to the beginning of the tape. Yeah, what should we do? Sure. We could have n more states that all go left. We could have one state that goes left and keeps going left until it finds the triangle. We want to do something where we're going to have a state sort of that's going to keep moving left. It's going to not change what's on the tape, so it can read anything. It's going to write the same thing back and move left until it gets to the triangle. And when it reads the triangle, it's going to leave the triangle. It's going to stay. And then it's going to move to the first state of the old machine. And we have no transitions back from the old machine to the new machine. We're done, right? We've constructed a machine that now writes the original input, rewinds back to the beginning of the tape, and now starts the old machine. So we can always do that. We don't need input. We can always incorporate writing the input into our machine. Other thing we're going to change, and all of these changes are things that we will see later, we're not going to see today, don't really change the computing power at all. The description we started with said the tape was semi-infinite, meaning it was only infinite in one direction, and it had an end in the left direction. If we think of modeling the scratch paper that the human computers are using, it's easier to think of semi-infinite. You don't have infinite in both directions. But we can model infinite in both directions. So what do we have to change? Okay, yeah, good, yeah. All we got to do, instead of using the max here, it actually simplifies things, right? The max was there to say we can't go past 0. So now we're still going to start at 0, but we can go left or right. This is I equals 0. We can go left as far as we want. We can go right as far as we want. Do we have to change anything else? Good, yeah. We might want to change the output, right? We might want to say we shouldn't ignore everything to the left of 0. We're going to make the output everything that's on the tape between the furthest blanks in both directions. We could decide, let's ignore the left side of the tape, but I think it makes more sense to include it. All right, so we're going to have to change that as well. So here's how we change it. We're going to have two sides, and we're going to capture everything between them.